And hello YouTube. Also, if somebody's watching me after the stream, you know, all the broadcasts of streams are available on YouTube. You can rename it later. Okay, thanks. Well, but just in case, let's name it something reasonable. Warsaw, like in case, just in case. Or last year we had some stupid name like Warsaw Erecto. So what will this be? What kind of animals are cute? Warsaw Kings? That's... No, I don't like it. Warsaws. And today, for the time of around, let's say 2 hours, I will solve this practice problem. I need to create a team in order to submit this. Warsaw Husky. Husky is indeed cute, but it would be Huskies. Well, Poland is quite cold, so maybe. Is this how you spell Huskies? Or Huskies? Yeah. Well, it's fine. I still hope that you can rename it. Oh, yeah, it's the button is here, so cool. Right. Next step, form a team. So what? I cannot. Damn it. Oh, I will just leave the team. Yeah, after this stream I will leave the team and that should be fine. Yeah, okay, so no worries. I thought that, okay, you can retype this link, but then this is not an issue if I can just destroy a team and then join a new one. So yeah, form a team. Oh, I need 2 members. All right. If somebody is, if somebody wants to retype this link, oh, actually that wasn't a full link, then you can. And if you join me, there will be 2. But I'm removing this anyway. Put link in the chat. I don't know. I will just send a link to my friend or something. Right. Let's read the problem. Even more pizza. You should usually skip the story. Help the imaginary pizzeria choose the pizzas to deliver to hashcode teams. We want them to enjoy their food. Deliver to each team as many different ingredients as we can. Every pizza described by some ingredients. Face too bright. What, my face? What do you mean? Also, this camera should point more down. But not that much. Where can I make a team? On the hashcode website. Each team ordered 1 pizza per team member. Right, 4 pizzas for 4-person team. Given the description of the pizzas available, number of teams of that, which pizzas to send, maximize per team the number of different ingredients used in all their pizzas. Right. Number of pizzas available. This, that. Number of ingredients. Oh, there can be 10,000 ingredients. That's a lot. All right. We have some kind of sets of names of ingredients. We need to distribute them into pairs, triples, and quadruples, like fours, to not get a lot of repetitions within the same group, so that there would be a lot of different elements. Is this a flow problem? No, and don't expect there to be some optimal solution here. I mean, some polynomial solution that solves this optimally. No, I don't play GeoGuessr. GeoGuessr. Right, let's download something. Okay, I already have 2 people, so I will be able to submit, I think. Yeah, I create a new submission. Cool. Is Santa real? Don't spam too much in the chat, all right? All right, this will be Google hash code. Let's read the input and let's try to just solve the sample test in any way. I can move the tests example as a.in, let's say. B, a little bit of everything will be b.in. One test, another tests. This seems almost like real life. I'm guessing that then later tests they will have just random strings instead of proper words like onion. Will you advance to CodeGem World Finals this year? How can I know? I don't know. CodeGem versus Hashcode. CodeGem Hashcode is optimization contest, and it's for teams. All right, I don't want to display this. And this thing as well. Well, again, let's hide this. No, now I don't have some unnecessary space. This is the practice round, right? When does the actual hashcode start? In 2 days. It's on Thursday, around 48 hours from now. All right, let's do this. I know that I recently said I will try using sin and cout, but in a real contest I will still use what I know best. So what's the input format? Input dataset. First line contains numbers M, T2, T3, T4. I don't know if that's the best names. Number of pizzas available. Number of pairs, triples, and quadruples. And then there are pizzas. If we read something, there's integer. Then a bunch of strings between 1 and 20 characters. Should I go with set? Let's go for now with vector. Later I will cast those strings for sure to indices to, it's easier to handle numbers rather than strings. It's not that the program will care that this something is called onion rather than free. Ingredients, better name for that will be... Ingredients is a very long word. Factors. For now, inks, like ingredients. 2 people joined your team. Okay, somebody indeed retyped the link. Congrats. Yeah, but the buttons are still here, so no worries. Inks pushback string of s. Right, this is red. I'm doing this warm-up today mainly because I didn't do any optimization problems for past half a year at least. Well, I did one where I could win PlayStation 5. I didn't. I missed by 1 spot. That was quite sad. But other than that, I feel a bit rusty, you know, with optimization. So this should be a nice warm-up. And the real contest is in 2 days. My plan is to first just try to make anything that will produce a valid output, like put pizzas randomly, try to compute the score, submit, check if the score matches, and then we'll try to improve that solution. That's what happens during a real contest as well. Coding game? Nope, I'm talking about some other competition. I don't remember the name. It was 32 bits coding challenge. Yeah, so what will I need to print? Number of people in the team, list of pizzas, right? If there are at least 2 pizzas left, should this maybe be an array of size 5? For every size from 2 to 4, if I read t of s, then here I can make some kind of for loop. With sizes from 4 down to 2, if I have enough pizzas left, then I will just grab this number of pizzas. Like if I see a 4-person team, just let's assign them to some 4 pizzas. And I will, well, we can just print it. List of pizzas. Indices. What are the indices of pizzas? Are they 0 indexed? Summation file. Well, from this 0, I'm guessing that it's from 0. Alright, then print s and repeat that many times. So when reading the pizzas, here let's go with iterating over index, and we will pass this index. Alright, now pizza knows its own ID. Print pizza's back ID. Pizza not present. Pizzas of I. some new lines, and we're good to go. Four, 4, 3, 2, 1. I'm guessing that we should also say what's the number of those. So let's do that. I need to gather them. Well, the easiest way to do that is just create a vector of vectors with output. So this is one delivery, let's call it. Delivery pushback ID of this new pizza. And then we print it. All right. Now, after this compiles and runs properly, I will submit this. I will get some score, but then next step to do is to also compute score in this code to make sure that I'm reading properly and properly understanding what's the scoring. For every delivery in the output, print the size. Print all the IDs. And a new line. Live streaming during competition? No, I'm not allowed to do that. Output should contain, of course, the delivery. No, during any real competition, you cannot stream anything because that allows for some cheating. All right, let's now create a submission. Create new submission. What do I want? This. No, not this. I want outputs. Like that. Choose a.out, choose b.out. For now, I don't even bother with bigger files because I would just waste time on that. Right, I'm getting some points. Caro Codes from University of Warsaw. No, I don't know her. Your template in some video? No, I'm not going to, but you can find in Codeforce's discussion on Warsaw templates. Right. What do we do? Yeah, I was supposed to compute the score. And also I'm going to grab the statement, upload it to GitHub so that you could use it. How to do it? I will do it on my other monitor maybe. Actually, I have GitHub here, right? So copy from downloads. What is this called? Practice round. .pdf. And now I have something like GitHub. What was that? Damn it, I don't remember my directories. Wait a minute. It's here. I thought I tried that. Oh, I see. Right, YouTube and then Google Code Jam. Hash code. Oh, I even have hash code. This is 2021 practice.pdf. right, it should be done. Sorry that I'm hiding my screen right now. I'm scared that I will show you my password or something. Hash code, this. All right. Do you stream on YouTube too? Yes, I do. In the chat, I pasted link. Also, I will make it into a comment, so that if somebody joins a stream, they can look up the statement. Right. Now, if somebody joins and asks about the statement, just run the link command. How to distribute the working hash code? You can watch my past videos. I talk about it like from a year ago. So some people analyze tests. One person does the visualization. The coding can be split usually between two people if you can really split the work. Like, okay, you need to write this kind of special kind of Dijkstra, and I do the rest. Or okay, you read the input. I assume that I have this kind of struct, and I will do something with that. Or I focus on the greedy approach to get some output, and you focus on improving it later. Yes, it's a team competition for teams of 4. Right. Now the scoring. For every delivery, is delivery enough for me? Well, yes, if I don't change the order of things here. Well, I'll just call it set. For every ID in delivery, for every string in pizzas of ID of this set insert s, what's the scoring? Square of the total number of different ingredients of all the pizzas in delivery. Oh, I didn't see that it's square. I thought that it's just linear. So it will be, I guess, important to focus on 4-person teams first, I think. Score plus equal set.size times set.size. Score, nope. What did I do wrong? Pizzas, oh yeah, I pop back from pizzas and then I try to access those. Let's try to modify it just a little bit. I will go with next pizza to use. First it will be pizza number 0. If s plus next plus s is at most pizza size, then I have enough pizzas to serve this team. Then I create the delivery, and for each guy we push back next plus plus. Is that easy? Yeah, that easy. Score of 49, score of 179. Is this, well, my answers changed. Where are my scores? Oh, here they are. out, b.out. I will always just run this command, I guess. 49 and 179, create new submission. What can I zip? Single source for all zip. Okay, I thought that maybe I can outputs put in a zip archive, but I cannot. Should be 49 and 179. All right, scoring works. What keyboard do you use? See frequently asked questions. That's some old Logitech keyboard. And now let's do something better. Always, when getting the next pizza, I can go through all the pizzas and see which of them gives me best score. So let's do that. If there will be a lot of pizzas, then it becomes bad because it's quadratic, but still sounds like a good idea to do. Oh, first I will download all the tests. How do I do that? Like this, many ingredients, many pizzas, many teams. Right. Many ingredients is C that's in. I could even move maybe. D.in. The titles are actually meaningful, I mean file names, but I'm going to eventually analyze tests if I have enough time, where like it is valuable to open something like many teams. Let's open E and see, this is the input. So this time indeed the names of ingredients aren't meaningful, they are just like XC instead of onion. So they are obviously not hand generated. They are randomly generated with some, not necessarily normal distribution. There are some very unusual properties to be detected in this kind of input. But yeah, some pizzas have a lot of ingredients, some do not. It isn't guaranteed that nothing is really guaranteed about the distribution here. Maybe there will be a lot of the same kind of pizzas, like exactly the same set of ingredients, and you will be hurt a lot if you combine such pizzas, obviously. QWERTY, yes, I am on QWERTY. Right. So let's run this. Let's create a script maybe for X in A, B, C, D, E. Do print X, run pro on input to produce output, and done. All right, and now let's submit CDE. Out. Just taking a look if the answers are all right. Yes, they are. And now, only some pizzas are used. Always, if, well, let's maybe count the number of used. If count used. Wait, do I use only one pizza? I don't use T of S. What's going on? Repeat that many times and do this, obviously. Yeah. Okay. My program wasn't really the smartest. Repeat that, whatever. Now I have some bigger scores. The rookie contest, you have some leaderboard, and then if you make a huge mistake, like here, I didn't have more than like one team delivered, one team done per every size, 2, 3, 4, I would see that somebody else has scored 1,000 times bigger than I do. So I would realize the mistake. Right, so now we have some millions. 200 million in C. Right, but then, as I said, taken for everything if no, used is a little bit better name. Do you parallelize your computation? Right now I don't, but I know how to do it. It's not really that meaningful in optimization problems. You know, it's nice to use like 10 times more the power, but don't expect 10 times the better score. In optimization problems, your algorithm is much more important. Used and count used. If I have enough pizzas to serve this team, there is some current set of string that already have. I have or already ingredients already here. And now for every pizza, if not used, we consider adding it. Improvement. What's the improvement? We need to iterate over ingredients in pizzas of ID inks. If not present in string in set already, improvement plus plus, and I need a pizza with biggest improvement. Improvement. This, in case of ties, it will resolve it by ID, but whatever. It's not that I prefer, for some reason, smaller IDs. But that was just once. I need to repeat it that many times. As times finds the best, delivery push bucket. And for every ingredient in that pizza we chose, say that we already have it. Right, right. Something missing. Delivery. What have you done in the repeat for loop? I'm unable to keep up with your typing speed. Which one? For every size from 4 to 2, I go through all the teams with this size, and I say, if I have still enough pizzas to serve this team, here I try to assign some pizzas to them, and let's say that there are 4 people, so I need to assign 4 pizzas. 4 times I need to find the best pizza to give them. Every pizza that is still available, I consider giving it to them and seeing how much the score would improve. Oh, what's going on? All right. Bounced. Used versus not used. Like for every ID, if not used, then something. Yeah, this is fine. Next. Yeah, I don't use next. By the way, I should have remembered my previous code, maybe. Actually, am I able to? Oh, good. I'm able to get my previous source code if I lose something. S. Right. This is more like size, I guess. Size, size, size. dot ingredients. Oh, failed. Something is wrong. Why not sort according to the number of ingredients? Why would I? I don't want to waste pizzas with a lot of ingredients with each other if they have some common ingredients. No. What I'm doing is better than sorting, because always I try to greedily choose the best option. If count used, oh, I don't increase count used. All right, so I guess I can do it as well here. So previously I had here 7,500, and now I have this almost 9,000. But this is now quadratic with a big constant factor, so it might run for minutes. If I really transfer minutes, I will, well, at least add some printing so we would know what's going on. Maybe I should skip test C. Count used times 100 divided by pizzas.size. Let's run this again. Nothing is being printed. Why? Oh, CRR. Now to terminal, I will print some information about the progress. This isn't flashed or what? Oh, it's just that slow. Well, it's very, very slow. 1% done. All right, at 2% I will kill to estimate the speed. 2% in 13 seconds, so 100% in this times 50. That's 500 milliseconds. Well, quite slow. Then let's skip C for now. But D isn't significantly fast either. Neither is E. Right, they all have a lot of ingredients or pizzas. Well, if this is the number of pizzas, then at least I have this square multiplied also by ingredients, because I use heavy sets. So we need to speed things up. Right. How do I choose the pizza? I consider each of them and I see how many new ingredients it produces. Do you accept subscription? No. Why is C causing the problem? It's the first big test. Right, now I have this heavy set. If number of pizzas is small enough, I could first iterate over all the pairs and maybe compute their difference. No. What about this speed up? If I already consider some number of pizzas, let's not consider them anymore. That might be a good hack. If something is not used, if tried or tested is, let's say 50, break. So not a lot of times I will try to go through the strings. That should be some nice hack. Yeah, and now it's very fast. Apparently E is still taking a lot of time. E is many teams, right? Apparently in other cases we have a very small number of teams. 5 seconds for this. Well, then let's run it for 200 pizzas tested every time. And we can see how the scores are improved. 207, 228. That's a nice improvement. 148, 149. This didn't really change. So only in C it matters to try more. Two, 5, 5. The scores actually show that I should use different parameters, and for C I should try more stuff than for other tests. But the time didn't change that much because I spent time on other things as well, not just on this part that I'm optimizing now, that I'm speeding up. So let's do really a lot more. And this is something that I can submit. It will be a reasonable score. Next step is to make this faster, and for sure I need to get rid of strings. Strings are very, very slow. Whoa, is that real score? Real score? Apparently I'm very far away from optimal solution if it improved that much. 255 and now 386. But submit just in case. If you don't spend a lot of time planning and instead quite quickly implement something like this, very simple approach, where I always try to consider a lot of new pizzas and I see which of them will match previous pizzas the best. This is enough to be at the very top in, let's say, half of the competition. It is not enough to win. It is not enough to qualify to the finals, because in 4 hours other teams will make something better, but it's a very good start. And you shouldn't be scared of quadratic time complexity. It's fine. By the way, the easiest way how I can parallelize that is to do this, then wait, and now it should be significantly faster. Like here I needed to wait 30 seconds, and now I run tests in parallel. Actually 3 of them are already computed, but this should be, I hope, like 15 seconds. Am I right? Yeah, 16 seconds instead of 28. So if you have a lot of tests and at least 2 of them take a lot of time, then you can very easily make them parallel. Max you can get is around this, 730 million. Makes sense. I can believe that. So I have right now around 400 million. I got 712 million on C only. Well, then I'm quite far away from that. But now the speed up. Though I can, of course, increase this bound and just run it for more time. Even if it runs for 10 minutes, that's fine. And as it goes, how do I get rid of strings? After I read everything, I need to cast stuff to ints from 0 to number of different ingredients, -1. Alright, or some other alternative is to make global map. Map is quite slow, but it will be used only while as I read, so it's done once. I don't mind. This is mapping from ingredient name to ID. Not ID of pizza, just to some unique value from 0 to something. And when I see a new thing, this is now int. with mapping count of this. Push back. Right, so this is array of characters. Then there's a string made out of it, still running. If map doesn't contain this string, then what to put here? Mapping.size. Like if it's empty, the first one will be 0. Yeah, that should work. And then push back mapping of s. Right? I got 8.0 instead of 6.8 in some test. Right now the order is changed because they are run in parallel, so whichever finishes first, I see the score. But all right, and yeah, that's much better score. Let's submit this. We already have 700 million. Nothing beats good old strategy of just choosing the best next step. Why is the char array static? So that I wouldn't create it every time. So it's like if it was global. Right, now it's the total of 720 million. And people in the chat said that this is already close to maximum, so it's not that I will get something much better. Ordered or unordered map, doesn't matter. This is not the bottleneck of a solution. Now let's try to achieve the same instead of in 2 minutes, in like 10 seconds. So I could do more with my code. So I already use ints instead of strings. And then, well, first improvement. Let's use set of ints already. Is that it? No, int. This already should be less heavy. But let's change back to the previous version with 2000. And that previous version ran before in 16 seconds. And now it's, I hope, around 5 seconds, but it seems that it's still a lot. 7 seconds. All right. 16 down to 7. Fine. Twice faster. But real speed up will happen if instead of this, I create some kind of Boolean array of size mapping.size, I think. It's static again, not to create it every time. Maybe it should just be a global Boolean array and then it will be even faster. I'm not sure about that. Already. If not already of s, then this for everything here already of s is true. So now I don't need to deal with a set. But finally, I need to clean the already for every ID in delivery, for all the ingredients. Then that should clear it. Anything else? That other part is fast anyway. Oh, now this thing got computed first. So we speed up a lot, test C. 6 seconds instead of 8. Something, but maybe we'll see much bigger improvement if I do this. Because now I speed up this part a lot. It was previously 2 minutes. And most of the time was spent on test C, I believe. Which test is that? 802. That's test E. Right. Let's go with now 4 instead of 2. Also, from 2 minutes we got down to 24. Nice improvement, if you ask me. We are not improving C anymore with this. This got improved by a lot, if that's the same number of digits. All right, so the test with 3, 7, yeah, test the D. The one with many pizzas, right, makes sense. And in E, let's see if it improves at all. But the next thing to do will be just to remove this completely and to just say that always we try all the pizzas. 9, 1, okay, this is nice. But not as nice as what will happen now, where always we test all the pizzas. Or maybe before that, before I do so, let's see if something changes. No, I just want better time. Oh, I cannot kill that. All right, let it run. If with Control-C I kill such a script, I need to add something to s.sh so that Control-C would kill everything. I had something like that for Facebook Hacker Cup. I would need to dig through my files to find it. Because now there are some zombie processes. What I wanted to check is what if I go with first pizzas of size 2. Will that help for any test? This is 20,000. Previously 20,000 version was, I believe, this one. No, that's 20. Yeah, that's 20,000. $11,000. Test B improved by a little bit. Then C got worse. This got worse. And what about the final test? From 802 to this. All right, so it's much worse. This was actually better for test B, but test B is just a few thousand. So for now, it's stupid to spend any time optimizing that. Kill all. I mean, I don't know what exactly to type here. I know it's related to some killing. All right, so we get back to this. We remove this limit for the number of pizzas tested. We check everything and we go from size 4 down to 2. All right, this is the best thing I can have right now without really big improvements, big ideas for what to do differently. I could maybe random shuffle pizzas, like at the very beginning or at any moment really. And then the scores will be just a little bit different. Oh, I forgot to run time. Well, I will do that later. What's the next step? I shouldn't just spend 1 minute looking at my code. This, I believe, well, the preprocessing to just read values and do the mapping, that's fast, because I do it just once. Anything that I do once, I don't mind. Later I have this quadratic part, so of course, whatever here inside, this is actually crucial to speed of my program. But this is done just now by iterating over ingredients, so yeah. For x equal to 0, I just choose the first pizza. Then this part doesn't matter at all, and it's just comparing by number of ingredients in a pizza. So if pizzas are sorted by the number of ingredients, for x equal to 0, so to choose the first pizza to give to some team, I could just choose anything with most ingredients. Maybe random one of them, if there are ties. That will make program faster, but not significantly faster. For 4-person teams, it will be faster by like 25%, right? All right, let's submit this. There was discussion on Codeforces about this problem. Maybe I will now take a peek to see what are the scores they have. I don't want to read anything about the strategies. Right, we improved by like 6 million. We have now 725 million. But come on, you don't need to... Oh, okay, no, never mind. I wanted to get angry at some comment, but I misread. Will you upload code somewhere like on GitHub? Sure, I can upload this code later, but you should mainly focus on what I'm saying rather than the code. I feel like in Python this quadratic algorithm might not be feasible. I need to learn C. You know, it might be 3 times slower, maybe, but that's not a big deal. If my program takes around 1 minute, maybe your program will take 3 minutes, maybe even 5 or 10. That's still fine. You have 4 hours actually to run it. Algorithms beat speed, let's say. Unless it's, you know, magnitude of difference, like 100 times, then that helps. I have here like 16 cores, actually 12. This is virtual machine, so outside I have 16, only 12 are allowed here. And if I see that it's useful to use many of them, I will, and then yes, sure, that's another 10 times speed up. You shouldn't release, actually not even 10 times, even if I use all 12, there will be some issues because I do things in parallel. Unless they give me 12 tests and on each of them I want to do some computations for a lot of time. Yeah. Then I can do perfect parallelization. What a hard word to say. Yeah, that's a very nice machine. So that was 1 minute. Can we improve something? I could try to find a good pair of pizzas. Or like after I'm done, I need to do some investigation. Show me the outputs. 4 out of 4s, out of 3s, out of 2s. Can I do 2s optimally? Maybe this is some kind of flow problem where given pizzas, this is like maximal matching with values, but in general graph. That's NP hard, right? Unless I say which pizzas, if I split pizzas into 2 groups, then I can run Hungarian algorithm for that. And this test C, it 1600. For 500 remaining pairs of pizzas, so around 1000 pizzas, I could optimally split them into pairs after I say, all right, I split you into 2 groups, each of size 500, in total 1000 pizzas. Actually, how many pizzas are there in this test? There are 10,000 pizzas. 500 times there's 4-person team, so that will eat 2000 pizzas plus 1500, that's 3. All right, so we have a lot of pizzas left and we need to choose some pairs out of it. Can I do Hungarian algorithm where I say that only some of them should be matched? I don't think so. I can run flow, but then it's too slow. Maybe not. Yeah, so this last part with just splitting it into pairs, I think it can be improved a lot with some polynomial algorithm. All right, that was test C. What about D? We have a lot of pizzas. A lot of 4s, a lot of 3s, and a lot of 2s. What about E? During a contest, a teammate of mine would do analysis of tests if I'm the one to code the main solution. A lot of 4s, just 4s for now. Right, only 4s in test E. What were the names? Many teams, many pizzas. Let's see the first line of C in, D in, E in. We have, in D and E, we have 100,000 pizzas. In E, well, we will assign everything to 4-person teams. So E is just about splitting 100,000 pizzas into 25,000 groups of size 4. How is your code handling the case? 4 pizzas of type A, 4 pizzas of type B, 2 teams of size 4 and 4 teams of size 2. I don't know, but you're asking about a very specific case, and it's not that you should spend time optimizing this kind of small test that might occur. Unless we notice such a property in tests, I shouldn't really optimize for something that might happen. Somebody can just check in tests if this is happening. If like there are a lot of pizzas of the same type. And I expect during a contest if I'm the one to code the main solution, I expect somebody else to analyze the tests. How to visualize inputs? Yeah, in Python it will be best here. It's not really that you need visualization here unless the graph is too big to, make some visuals, to draw nodes and edges. Maybe you can take some small sample like 100 pizzas and analyze, and where every edge will have some weight, like the number of ingredients in common. But mostly it will be graphs about statistics, how many ingredients per pizza. In my solution, every next pizza, how much waste is there, something like that. Right, how can I improve it? The easiest way that is valid in a lot of other problems is to later, when I have some output, try to swap some pizzas around, because maybe it will improve the score. But with sets of 4 pizzas, it will be very hard because they already create a good match. Let's think. I will grab something to draw. Where I'm from? I live in Poland. In Warsaw, to be exact. For small test cases, can we take a brute force approach? Yes, for the very first test, usually it's best to solve it by hand. Live in Poland too? Pole Mokotowskie. I hope you don't live in Pole Mokotowskie, because it's just a park. But if you live nearby, then all right. Now, this would be a part where I want YouTube, I guess. Yeah. This would be the part where I stop coding and I just sit down with pen and paper. Maybe also talk about ideas with my teammates. Right. I have some first set. There will be 4 pizzas, A, B, C, D. Then I start choosing the next 4. For now, for simplification, let's assume that all the sets are of size 4. E, F, G, H. What can I do with that? And so on, of course. But maybe already after choosing 2 of them, I should consider some swaps and see how the answer changes. because when you choose A and you just want to maximize the number of ingredients there, then you choose B, then pair AB is quite nicely chosen. But then you choose C. It will match quite well both A and B, but maybe then after you choose C and you choose D, maybe it's better to replace A with something else. Maybe after creating quadruple, I should go through all of those and consider replacements. Audio is too low? Can somebody confirm? Are you participating in hashcode? Yes. How did you guess? How can I rewind the video? You can go to YouTube. I stream on YouTube at the same time, and there you can rewind easily by 10 minutes, half an hour till the beginning of the stream. Previously there was a nice comment. I will refer to it. Wait, why can't I? Right. Can you divide all pizzas into blocks and solve problem for small chunks and take the best? Here's the thing. Sometimes it is a very good idea, because maybe for like 10 pizzas I can solve it optimally by checking all the possibilities, but it will work very badly in this problem, just because for every pizza or even like pair of pizzas already chosen, if I have only 20 candidates for the next pizza, this is very small choice that I have, and I will have some unnecessarily common ingredients. It's so much better here to choose from a big pool. Notice how much my score improved after I allowed my program to consider a lot of pizzas to match with the partially built set of pizzas. So sometimes this is very good, and this is what we used in hashcode finals from around 2 years ago, where you need to build a city with some kind of buildings, and they need to match each other. Like, let's say I see that, okay, this building matches this one well, then there's this other kind of building and they have a nice combo. And then what we did is we took this pattern and we repeated it, 4 times, let's say. So we did this in a problem from finals around 2 years ago, but it will not be a good idea in this problem. At least I think it will not be a good idea. Do you calculate the theoretical maximum? Good question. Yes, it's very important to know where there is some space to optimize. Maybe it's possible to easily realize that already we have optimal solution in E. My teammates would do that. Maybe I would just provide some idea how to do it. Again, assuming that I do the main coding part. But because leaderboard, I think, only displays the total score for each team. So I wouldn't know during a contest which test I should optimize. That being said, still my solution is so stupid, so simple, that I shouldn't, I think, look into tests yet. I should mainly just get some better idea for a solution. Cout never does a new line? What? Say louder and little slowly? I mean, if few people tell me that I am the voice is too loud, then I will speak louder, but I doubt that's the case. Regarding slower, I don't think that's a good idea. I don't want to be slowed down by speaking too much. Don't repeat your comments too much, remember. Also, yes, you can even make my code randomized by saying random shuffle, pizzas begin, pizzas end. And some simple kind of optimization. What you can do is you can, with different seed, run your program multiple times for different orders of pizzas. Here you would need to fix the IDs, and it will change the score a little bit, but yeah, for now it's not important to do this. Instead, let's keep investigating this idea. What do I want to do? We can try all permutations or graph matching. Yes, indeed. If there is some test where the number of ingredients is like 10, so there are only small number of possible pizzas, then we should do something else indeed. But let me investigate this. What will I do? Yeah, after building a quadruple or just any kind of set, iterate over them again, and each of them just consider replacing with something else. Should I do something with like a pair of them? Like swap around? Maybe. But if f improves the first set, then we would use it before. But maybe a is very beneficial here. Maybe a is a perfect match for this. Maybe this will be a better example. D wasn't perfect for the first quadruple. It was fine, but f was equally good. But then D right here, it would be much better than f, because D with E is a very good match. So maybe as I partially build stuff, let's say that previous quadruple was ABCD, or just any previous, not necessarily, you know, the previous one, just anything that I already built, iterate over them, and consider some swapping, and maybe the total score is improved. Well, for total score, I care about the square of the number of ingredients, and I don't know those ingredients yet. Well, I think it's beneficial to consider this. One more thing to try is if there are ties, like after building AB, then there are for sure many possible optimal like third pizzas. See, so maybe I should try few of them. That might be a better idea than trying the swaps. Can you say the issue right now once again, please? There is no issue. I'm just thinking about improving my algorithm. No time of the running time of your code doesn't matter in hash code. You just need to submit the output file, as long as you can run it in your computer in 4 hours, because that's the deadline for a contest. You can use a tree for each one. I don't understand what kind of tree. All right, I'm going to now try this. When building every next quadruple, always when there are ties, you randomly choose which one to take. And this should produce a lot of different quadruples to use, and I will just choose the best one. I think that should be quite good. So, repeat that many times, if this is a good case. Okay, now, here, everything here is to find the next good quadruple, or not, just delivery, next good delivery. Let's make it into a function. Find good with the given size. Like this. The style of code shouldn't matter during contests. I mean, it doesn't matter, so it's not that you need to make perfect code. But if you see that your code grows and becomes ugly, then it's good to make it more modular and generally do some refactoring, just to save some time and bugs in the next hour when you're working on it. But it's not code that you want to support later in a year from now. So don't try to make it very nice. return already. Used. Right, now used is available. M can be global, I don't mind. Pizzas, well, pizzas I will make global too. Something else? Not already. Return delivery. To make it fast for now, I'm decreasing this number of tested to like 2000, just because I want it to run in few seconds. And produce some scores. Alright, what about this? I can go through IDs in random order. Or just in this order and randomly override? Let's go with random order. If not used, I can do it here. Random shuffle. Then for every ID in IDs. If not used, I still need to check this because maybe I used it a moment before. All right, will the answer change significantly right now? What is this? Maybe for C, thanks to random shuffling, the answer improved that much, but it's surprising. Can we do bit sets? For which part? It seems that the scores improved significantly, which is nice. Maybe because always when I went from the beginning, from small IDs, I always was left with some very bad prefix of stuff. I'm checking if maybe something improved. Not really. All right. And now the trick is that we can do it multiple times. Pair of int, this is the score. Also, I hope that I don't have any overflows here, but if the number of ingredients can exceed like 30,000, I don't know if that's the case in tests, then I have an overflow here. But I print the score properly, so I hope that's not the case. But if during the problem sometimes I don't consider a set of pizzas because it overflows the score, that would be sad. Anyway, vector of, where do I find good? Right here, best. Best first is, say, -1. This is just pair. I maximize the number of ingredients. Now repeat, can I use repeat? I can. Or more like try. No, try is a keyword. Tries. That many times. All right, create delivery and IDs. Random shuffle IDs. This we can do once here for some speed up, because for every next try the IDs are the same. Create delivery that many times. Find the best here. Okay, best is used. So this is more like best delivery, where first value is just the score and the second is vector of IDs. Find some delivery, sure. Int count ingredients is 0. Count ingredients plus plus. Pair count ingredients and this IDs. What are the IDs? Delivery. Return. What about used? I should cancel it, right? Yeah, I should. Return best delivery second. First, maybe let's run one by one. 16,000, what was it before? I don't remember. Oh, I can check here. All right, 16,000 would be very nice. Let's check if this 16,000 is valid. It's invalid. I all the time print the same pizza. This is the output, and I repeat the same set of pizzas. Because here I need to go through IDs and mark it finally as used. Write a script to run continuously and keep saving improved scores outputs. I mean, yes, I can eventually do that. Now the score didn't change. Oh, it becomes 10 times slower. That's bad. This is running in parallel. For C we got 697, so not really better, but also we stop after 2000 tries. 738. I don't know if this became any better. Oh, I need to shuffle here, of course. Otherwise, each of 10 times I try everything in the same way. Right, let's try again. 6974, and also there's maybe first B. B didn't change. 6974. 6974. All right, it improved from 6974 to 702. Still doesn't beat this, but it's because for now I only try first 2000 elements. And let's do the same for D and for E. This is 738, 103. 738, 103. What language is this? C++. Creating a subset of size 234 with minimum count of such bits. Are you just saying what the statement is? Creating a subset of size 234 with minimum of count of set bits. And more like maximum, right? Count of set bits. We maximize the sum of squares. Should we always look at input files first? No, I didn't. C++ 20 this year. I'm a slow learner. Or maybe a lazy learner. Right, after this is computed, what I need to do is I need to run this without that, which will take a lot of time. And for this, maybe I should write down some stuff. Repeat that many times if this. count used times this divided by pizzas.size. Maybe, yeah. Okay, it's alright. D and E already, okay, we got D, 7.5 something. What was it before? Did I remove the number? I did. From 738 up to 752. And 752 still doesn't beat that. We also have 103 to beat over here. But now I will remove this. Once every 10 tries, do this. Print the percentage of work done. I removed that. All right, let's compile it. A, B, nope. Thanks to running in few tabs, I will see separately for every file how much work is done. It's so slow that I guess I should just decrease this first, at least for D and E. So let's go with, or this could be argument from the input. Let's go with 4 for D. C is computed as 706, 523, so nothing changed. Maybe that's just maximum. And from 103 we got 104, right? Here I will go with 3 tries, because this will be very, very slow. And this would be wasted if I didn't do this. Right, do they have similar speed? Yeah, this one catches up. Right. And obviously, while this runs during a contest, you shouldn't just look at those percentages. You should do some work. Maybe like now I would analyze tests a little bit. Also, this is not the nicest kind of printing I can do. I could maybe create some bar that goes from 0 to 100, but during the contest you shouldn't spend time, actually you shouldn't waste time to make things nice. You should be efficient. So this is still a little bit behind. Maybe I made it too fast. Or actually those percentages, they only use number of pizzas, where maybe number of teams is limited factor. Well, so this will go on for like 10 minutes. A fork that tries into threads, how many cores do you have? I have 12, and indeed it would be useful to fork tries into threads, but notice that already I split it into 2. I have 2 files, so it's like if I had now 6 cores for every file, and 6 times the speed up isn't that much. Yes, it's useful, but it's not crucial. What about we check encode forces? Hashcode 2021 practice problem. Total 7 to 1. Well, I already have more. I'm looking, comparing test by test, if maybe somewhere I have worse score. Nope. Total 732. Okay, that beats us. Oh, in B you can do more than 10,000. 13,000. Then 714. That's much more than I have. 7845. a little bit. 15,000, not worth it, but also during a contest I wouldn't know that. 10, 7, 7, 3, 10,000. So only C is worth improving. In D and E, assuming that those are the values I want to get, D and E aren't worth it. Like this indeed, this should run, but I should focus on C, which is good information because my program is slow in D and E. Where in C I can do a lot more. He also says that the greedy part is important. Total 731, 725, 731. All right, so this is the best total score. Isn't there one problem in hashcode? Yes, with multiple files. I have 61 in A, then congrats. Yeah, but don't make a mistake of wasting time to get 10 more points. Right, D and E are being run. This is D, this is E. And we should instead focus on C. What if I change the number of tries? No, this was already run with this number of tries, right? So let's run this with 50 tries. I will do the note. Then if I scroll up, I will see that it now does 50 tries. But other than that, I should analyze this output. Maybe it's more that I should analyze c.in. This is the test. We have 10,000 pizzas, 2,000, 3,500, 4,500. Right, I have twice more pizzas than I want to distribute them. So I'm guessing that in particular we should discard pizzas that have very few ingredients. The first number in every line is the number of ingredients a pizza has. And I would say that discarding the bottom 20%, maybe it will not affect the score, but it will make my program much faster. I don't know. Oh, this is done after 25%. So not the number of pizzas was a limit there, but the number of teams. 783, is that an improvement for me? 329. Okay, this is not an improvement. But he has more, so just maybe this is some kind of maximum score for my solution. E is being run quite fast now. I guess it was sped up now that it doesn't have that many choices for every next position because some pizzas are already used. This also means that C is close to being done because this is percentage of pizzas used, but we know that out of 10,000 pizzas only 4,500 will be used. So at 45% this will be done? What happened? Oh, I thought that from 41% it decreased to 29. No, that was 28. Do you like CodeGem or hashcode style more? You know, I would prefer to see more hashcode style contests because there's just so few of them. But I'm not like CodeGem is my gem. Like, for 99% of my contest career, I did CodeGem style problems. So my calculation suggested that this program should stop at 45%. Right, I was off a little bit. 7065 23791. It's actually suspicious. It's suspicious that nothing is improved. If I change this to 1, will I get exactly the same scores? I got the same score in C. If something really doesn't improve anything, then it means you made the bug. Here it would mean I made the bug. So if in those two cases, now that I have 0 tries instead of 10, let's see, maybe there is some bug here that causes my program anyway to just do a single try. Let's read this. Code challenge problem. Yes, they have that, but they penalize you if you try to solve it. I did that in the past. You see, if you want to, fight against others in this challenge problem, you are automatically registered to the long challenge, the 10-day contests with 10 problems. And if I just want to practice with this challenge problem, the optimization problem, and I don't want to spend time solving other standard problems, my rating will just drop. That's not very good solution. It doesn't motivate me to participate. DE. Okay, all right, D is done. 783, blah, blah, 29. Right, D is also the same score, so E is left. But my working theory is that I messed up something. When tries was here 3 or 10, something should be better. Can't you solve after the contest? I can, but it's not the same fun. For every ID, if not used, compute the improvement. Find the best. Delivery pushback ID used is true. And already is true as well. I don't see a mistake. All right, is done. And 107, blah, blah, 32. Yeah, it's the same. All right, then something is wrong. Or because I don't believe that in every single test, it doesn't change anything. Can you participate solo or you have to form a team? Oh, I see. Yes, you can. You need to form a team because you need to have at least 2 participants. But I guess nothing stops you from creating your own team and then adding some fake account. I don't see. I have no idea why they forbid single solo participation. But yeah, theoretically, two people requirement. You can even, I guess, find stranger online. It doesn't matter that I go in random order because I decide ties by ID. I said at the very beginning of this stream, I said that I break ties by ID, but it doesn't matter. It's not that I prefer smaller or bigger ID. No, I should here say if improvement bigger than best at first, then this. Now the order matters. Now if I run this, I expect that something else, that I will get some other score. It just random order, so at least it will matter that it's random order. 706 to 9 versus 52. All right, so it changed something. That's good news. And now for C, if I do this, it will take 1 minute, will be 10 times slower than this, but I think that the score will improve by at least 1 million. Is that a million? Yeah. I hope to see 707. Add your parents, well, yeah, or like your girlfriend or something. Come on. Yeah, I guess there is no reason not to run D and E, but still they are slower, so let's decrease the number of tries. D was computed first, right? So D like that. Oh, I have times. Yeah, D was in 4 minutes and a half. So let's run D in 5 times that. No, wait, that was for 3 or 4. Yes, anyway, this. And E for 4. Right, this running here. 7806. At least it's different, right? I don't need you. Sure, you can finish. So see now, all right, I wanted 707, I have 706, something at least. I can try even more tries, but I guess if this doesn't give me much, well, let's go with 50 and it will run for 5 minutes. If this is not enough to improve the score by a few million, then next step to do is to just take the whole output and then try some swapping to improve the score, instead of just redoing a single quadruple. In particular, in C, we don't have a lot of ties. Maybe I should use this fact. In C, there are so many here pizzas for every size that generating random orders doesn't mean a lot. Still, I will most of the time try the same first pizza, try the same second pizza, just because of huge differences. While it matters a lot to actually try various combinations. So maybe I should make a change like, where's pro? Here. Like here, when I override something, I need to say if this new improvement is significantly better than the current best improvement. So what if we do something like, if improvement is greater than best first +1 or +2, +3. No, let's run this with decreased number of tries, just to see what kind of output do we have. So this is very experimental. D, E, what is this? This is Alt E. You can notice that now I stopped using the bash script to run on all files at the same time, but if for every file you need around 5 minutes, then the 5-second extra saved on the fact that you can just run everything at once doesn't help. I want to see what kind of score do I have here. Did I mess up a lot by saying that I don't need strictly the best? 7059. It isn't the worst. Right. If maybe here we have some threshold or something, magic. If x is size -1, then magic should stay as 0, because I'm just looking for the best one, because this is the last pizza. Here magic is, let's say, 1 when choosing the second last pizza. Third last pizza magic is 5. And here fourth last pizza, only if it's quadruple I'm choosing the first one. Magic is 10. I don't know if this is a good idea, but we can test. So we got, instead of 706, we got now 7068. Just a very, very small improvement. Not really worth it. It was that one where I used 50 here. I used 50 tries. So yeah, because pizzas have so many ingredients in this test, there are almost no ties. And my program so far, it just used the fact that if there are ties, we considered various possibilities. 7064. That's very promising. This kind of heuristic, it helped. I try more things. Let's beat 707. Are we doing machine learning? No, we don't. This is maybe simpler than that. Or maybe not, hard to say. We're just doing something greedy. If you have some huge data and you want to, very well split it into some, maybe not split it, like reorder it in good order to maximize some kind of function, then most of the time the best algorithm will be to just try every next thing and choose the best one that's greedy, and then improve it by swapping around. Well, we're getting close to 707. So I guess if I do this, and now let's save it actually to see that out in order to submit. We should beat 707. D and E are being run still. I don't like the fact that nothing is printed. All right, it is now. What question are we solving? There is a link command. You can see the statement there. Come back and see magic 0, magic 1. Magic is threshold for me to say where I overwrite something. Let me make some drawing to explain what I'm doing right now and maybe what the problem is about. Right, what are we doing? There are around 100,000, there is M up to 100,000 pizzas. For every pizza, let's draw a pizza like that. For every pizza, you're given a list of ingredients. There can be a lot of them. In sample, it's like onion, mushrooms, and so on. But actually, we can assume that it's any kind of short strings or something. For every pizza, you're given this kind of list. And let's say this one has ingredients A, B, X, and also onion. So there are 3 ingredients in common between those two pizzas. You're given around 100,000, up to 100,000 of them. And also, to simplify stuff, let's say we need to split them into quadruples, into sets of size 4. And in every such set, let's say I chose this pizza, this one, 10th and 15th one to be in a set together. For each such set, I count the number of different ingredients that are there. So different ingredients. So you want to choose various pizzas. So in total, they would have a lot of different ingredients. They shouldn't have ingredients in common to maximize this. And for such a set of 4 pizzas, you take the number of different ingredients squared. You add that to the answer. You need to maximize the sum over this, over all the sets of pizzas. Max over all the quadruples of number of different ingredients squared. That's the statement. And now my algorithm is that, well, there is that 100,000 pizzas or something. Let's say that I already used some of them. So some of them are marked as used. And I want to choose the next quadruple. What do I do? 4 times I go through this thing and I just consider every next pizza and I see how many ingredients it has. And for simplification, let's say I choose the maximum number of ingredients. And let's say this one. This one was the maximum. Then I want to choose the second pizza. I again, consider each pizza separately. And every time, instead of just looking at its number of ingredients, I cannot, again, choose this one. I cannot have repetitions. I always now consider such a pair of pizzas and I see how many different ingredients they have in total. And I choose such a second pizza that in total they have maximum number of different ingredients. Let's say this one was the best. And now you can guess already. I do the same with third and with fourth pizza. Let's say the third was the best one was here, and finally the fourth, it is somewhere, let's say here. But again, I considered all of them. You can, if you know what's time complexity, you can figure out that this is m squared in total, which is slow. M squared for limit of 100,000, that's too slow to solve a test in 1 second. But we're not limited by any kind of like time, like 1 second or 5 seconds. I can just run it on my computer. I need to produce output file and submit this output file. So this is fine, even though it runs in a few minutes. And after this runs, let's say in around 20 seconds in my computer, after some optimizations. And right now I'm trying something multiple times so that instead it runs in 5 minutes. So what do I do multiple times to make it run in 5 minutes to improve the score a little bit? So actually, instead of finding really the best blue, I want to consider a few possibilities for the first pizza and second and third. After I already chose 3 pizzas, then if I want to maximize score of this quadruple, then the fourth pizza, just consider all the pizzas and choose the best one, matching the previous 3. For each of them, see how many different ingredients we have and what score would this produce. Then sure, the fourth pizza, we should choose just the best one. But when choosing first, second and third pizza, maybe we shouldn't greedily make a choice, because maybe after I chose this blue, maybe with this second pizza, yellow one, yeah, they are good. They have a lot of different ingredients in total, also some common one, but maybe it will make it very hard to choose a nice third pizza. Maybe just this pair is a good combo, but together they have ingredients. Let's say this one has onion and tomato, and this one has ingredient AB and ingredient X. And maybe every other pizza, it has either X or tomato. Then this is a bad pair of pizzas, even though together they are fine, they don't have common ingredients. So instead of always trying to find the best next one, I multiple times, and that's the multiple means, let's say, from 3 to 50, depending on the test, how much time I have, that many times. I repeat this process of choosing quadruple by saying, okay, maybe this blue one, it doesn't need to be the best. Maybe something almost the best is fine too. So also I will try this one. For choosing the second pizza, I also say, okay, you're the best second pizza for me, but if this one is almost as good, it's also fine to choose you. So like that, around up to 50 times, I try to find some quadruple, and among quadruples I just choose the best one, so the one with most different ingredients in total. If m was smaller, then actually I would try all the m to 4th power quadruples, and I would choose the best one. Now multiply it by m, because that many times we choose the next quadruple, or actually by m over 4. But this would take not even years. That's, I guess, time until the end of the universe or something. So this is not viable. This is of magnitude 10 to 25. That will be billions of years. I don't know what's the predicted time until the end of universe. Right. So in C, we crossed the 707. In D and E, did we improve the score? Please be smaller. I don't remember a button to decrease this. It was Control up? Yeah, Control up. All right. So this is D. and instead of 783 we have 785. Fine. Now in E, 7075 to now 77. Sure. And in C, we have, instead of 706, we have our goal of 707. And then this. I just wanted to show you because I see that my camera is covering the score. Actually, this is also a way to go. Right, now let's submit this. And I guess I can also submit A and B. Still 49? Maybe I shouldn't go. Oh, I see. In test A, I shouldn't first choose something of size 4. Right, so in A, let's do a little hack. Instead of size 4, let's do size 3, because I simplified the statement. Actually, not always we choose quadruples. We need to make some number of pairs, triples, and quadruples. 74. All right. So this is A, then B. Maybe 5,000 is too much. Oh, not too much. That's some improvement as well. And time to submit everything. Remember that during a contest, I would have a whole team of size 4. This is not a solo competition, it's for teams. So you could achieve more, you can make more complicated programs, you can split some work, analyze tests a little bit more. I didn't spend too much time looking at tests, other than in C, I noticed that because the sizes are big, there won't be a lot of ties. So this magic heuristic I made at the end, maybe even I should adjust it a little bit more to find better quadruples. Right. So now I have 726 million. It's still much worse than they have, 732. And the difference comes from test C. Somebody shared their scores on Codeforces. What about other tests now? The last one, I'm just missing I'm short of 300 points. That's close enough that I shouldn't optimize it more. Other than I can, of course, treat it as a challenge. 852. Oh, okay. I beat them in D. 852 instead of 845. That's plus 7,000 for me. Then A doesn't matter, of course. They didn't bother to run it properly or open the input, whatever. In B, I can do something much better by a few thousand. It doesn't matter compared to 6 million, but just from curiosity. Let's see what B is. And how I can get thousands. Instead of scrolling, let's just open it. 500 pizzas. If I use everything, that's 260 plus 180 plus this. This is 300 in total. Okay, I will be short a few pizzas. In B is small enough that I can experiment a little bit more with those magical values. Yeah, this magic is for sure too big. Is this better for B? But don't waste time like this during a contest. Getting hungry thinking about all these pizzas. Yeah. Well, even if the problem isn't about pizzas, it's good to not to be hungry. Are you winning, Camille? No, I'm second place among people who shared their score in Code Forces. In one test, I'm short of like 6 million. And in other tests, I'm tying or winning, let's say. Here they have 714 million, and I have 708 now. Wait. Don't I have 708? Is my program wrong? Oh no, okay, I didn't remember correctly. I wanted to achieve 707 and I did. Yeah, right. I thought that maybe my scoring calculation is wrong. So here I'm losing by 7 million actually, not 6 million. Yeah. I got 10 million now in E. Well, congrats. 12,000 in B. Congrats as well. But maybe I will get B quickly now. Well, with such a small test, any kind of improvements later, like swapping stuff around, helps more, and I don't have that part. How many pizzas do we have in C? Oh, 10,000 instead of 100,000. So the swapping later to improve anything will be better too. In tests D and E, if you have 100,000 pizzas and you will make tens of thousands of groups, it's not really viable to go through all the pairs or just random pairs. They will not improve the score. But here, the number of groups is small enough that we can do it. So yeah, now the next thing I would do during a contest is to just take the output and try swapping two random items in the output and see if the score improves. That being said, I can just do it. It's not a lot of work. Just maybe I will grab water first. And maybe I will first test this idea on B, because B is much smaller, so I can do a lot of more swaps. If this is good enough, then running it for more time in C should do the job as well. Well, still also I'm not sure about the magical constants. What about zeros for B? Weird rule of minimum 2 people in a team? I guess so. They really want to make it a team competition, I guess. Those kinds of rules are often business rather than thinking about quality of a contest. Yes, this is Ubuntu. All right. So after I'm done doing the output, repeat 1 million times. Grab 2 deliveries. Maybe more like this. A, B, and just make some swap. Now I have score like this, then swap to random elements. Also, if they are the same, continue, otherwise some strange thing could happen. Swap A of A, B of B. Sorry about stupid naming of everything, but you know, if it works, then there's no issue. Now, so this is, let's say, previous score was, is, get score of A plus get score of B. If was smaller than is, actually smaller equal will be better. Then leave this change, else move back. And by leave this change, we do this. If was is strictly smaller than is, I will even print the difference. And we need get score. Long? Do I want to make it fast or not? Let's for now use just a set. For every ingredient in pizzas of ID ingredients, I think this works. And I don't want to spend so much time on the first part, because that's just a waste of time. 1300. Well, cool. What about we increase it a little bit? Did I say 1300? That's 13,000. Maybe now I should make it print the output like once every 5 million iterations or something to make it keep running, but you know, few hundred points don't matter that much. What do I want to beat? 13,200. I think I already beat that, so I'm hopeful about C. Why are you not posting on YouTube? You mean the main YouTube channel? It's just about time that I would need to spend for that. Right, B. No. New submission. I didn't write, I guess. Yeah, I didn't. And if I am to run this again, let's just run it for some more time. Maybe 14,000 can be beat. Though still here we have fewer and fewer changes. Like now it's +2, and every next change is more rare. Now it's stopped. So I think that we are in some kind of local maximum. Maybe it's not optimal score, maybe changing more than a single pair would be better. But at least this means that it's not that changing this to 300 million will do a big change. No, it will not. I could have left it as 10 million. Maybe I should now have a button to stop this and to give me a file. Or, as I said, once every few million iterations, it could again print the new output file, so I would have it, I could submit it. No, not D, B. 13,840 or 8, that's beaten. And now what about C? I don't want to spend a lot of time in the first part. Yeah, I'll just do it once. There are zeros here. Yes, they are. Later I will either make this first part like slow again to make a good first part and then improve it, or just I will split the two parts. I can grab the output I already have. I submitted something that was run on C for like 5 minutes, and I can run these improvements, the swapping part, after that. I hope that I printed to see that out, because I want to submit it just to make sure that it works. So what kind of improvements are we looking at? That's plus 15,000. It's very nice. Plus 10,000, I think. Instead of this, I should just print the delta. The new difference, it will be easier to analyze. 5,000. Yeah, this is looking okay. For sure, every next change will be harder to make, but for now it doesn't slow down to 0. And let's make this faster. This get score, because that's now bottleneck of this second part. Where is get score? Find good. Get score. Already of mapping that size. If not already, plus size. I'm using the same trick that I used before. And right now iterate again and clear that. But size is something that I already computed. This is still going on. Maybe 1 million was too much. But in parallel, I can run it as c2.out with some improvements. Like here, let's run plus. And now the change is minus was. And rep is I will know how much progress I made, then a new line. Oh, this is done. 7069. I wouldn't say that's great. No, but that was so much faster. And let's see how much improvement we have if I let it run for 2 million. Because if it improves by like 100,000, then let's just leave it running for 5 minutes and I will get my 710 million. It improved by 500,000. That's very nice. So maybe let's make it run forever, and once every something it will print a new output. Yeah, this, on one hand I'm lazy and I don't want to do this, but on the other I want to remember how to do it when there's a real competition on Thursday. And that's the last thing I'm doing today. After that I will finish the stream, but I think I will easily here beat 710 million. So this is like forever. Let's say starting from 1 and now. Once every million repetitions, let's use free open. What do we have? File name, modes, and stream. Right, let's say automatic.out, but we know that it's for file C, for test C. Write std out. Do I need to close it later? I don't remember. I could maybe, I know what I will do. Int I, which is this. file is, I will call it 1.out, 2.out, and so on, to string of which plus out. And maybe let's make a directory for that, not to leave some trash here. So it will be actually out slash this. Maybe like that. Right, this is going on. Now let's go here. All right, it creates every next thing. C1.out, C2.out. They have similar size, 27 kilobytes, so nothing is really messed up. I don't really see the score. Oh, I can see it here, 708. Right, so once every million iterations, it creates a new file, and I can scroll for a moment to see the score. That's not the best, not the worst. All right, we are getting to 709. If I get to 710, I will submit this. And another thing to do is, okay, this is not something I will do today, but I could read from the output that is already created, and I would grab this, the best output I have right now, which is this one. It was run for like 5 minutes with very good first part, the greedy part, and I would run this optimization on that. Yeah, but I know how to do it, I guess. Here instead I will just run it again for 5 minutes. It doesn't hurt too much. While we will wait those 5 minutes, I will talk with the chat a little bit, and that will be end of the stream. Also, now that I see what others got for D and E, and now nobody has significantly more, I'm winning anyway on D, and in E it's like few thousand difference. So it will be just a waste of my time to try to optimize them. And because there are so many pizzas there, it's not a good idea to do this second part. Maybe it's still a good idea, it will just not be very efficient. Oh, we crossed 710. Create new submission. Pro. C. Out. Let's wait for C30 maybe. 710 2, but it's like, you know, diminishing returns. Every next million repetitions should be worse, I think. Or maybe it's still similarly fast as at the beginning, I don't know. Okay, I crossed 732. This. Oh, what's wrong? Refresh. Okay, I'm refreshing. Pro. Submit. Do we have 730 now? Oh no, a little bit short on that. All right, so this can still run. I still have improvement of few thousand here and there. Can I scroll to the beginning of this process, or maybe I lost it already? Yeah, I lost the very beginning. I wanted to see if it used to be stronger, and yeah, I think at the beginning almost every time we had plus few thousand, and now mostly we have plus 80, plus 2, sometimes plus thousands. So it definitely slowed down. But we'll get our 730,000. And then what was the code that produced this? Oh. Because I want, I guess, a little bit different magic constants. Yeah, I don't want to bother with that. Let's just submit this in a moment, and that's it. I wanted to, you know, again run for more time this first part, but I think that this second part kind of overwrites it anyway, so not a big deal. But it was a very good idea to run this forever. Will I overflow rep? Not anytime soon. We have 558 million. Does the terminal uses ring buffer? I don't know what is ring buffer, but yeah, it doesn't remember everything. If I scroll up by a lot, like this data at the top is lost eventually, like this. Now I'm not touching anything. Is it okay to put Codeforces rating in CV if you don't have IOI medal or ICPC World Final participation? I don't think it hurts. It shows that you do something, but don't expect to get an interview just because you have high Codeforces rating. You know, just like any single project. This alone will not be enough. Should source the code be absolutely correct with output file? You submit source code mainly to for organizers to check if you really produce that output. It doesn't mean that they will run it and they expect the same output. Your code doesn't have to be deterministic in particular. But yeah, like if you copy somebody else's output file and submit some bullshit source code, they will figure it out. Especially if you're in the top of your region or top of the world. We have 7-11. It's slower and slower. If I finish the stream and don't close my computer for a night, I guess that tomorrow it will be a little bit stronger. It might beat that other high score from Codeforces. That being said, I don't know what will happen after overflow, but I think just rep will become negative, and it's fine for file name. I hope. Will be with minus. Yeah, I think it's fine. But really, if I don't want to worry about it, I should be able to read from output file and then keep improving on it, which isn't that hard. It's just about reading vector out of vector's output. That's easy. Also, eventually, when this gets stuck more and more, I should use parallelization to, you know, split into 10 cores. Each of them will try to find an improvement. Once somebody finds an improvement, they all work on this new output. This is not viable at the beginning if they once every millisecond find some new improvement, if that was the case. But later, if now once every second or so somebody finds an improvement, that would help a lot. Running with multiple threads for 1 minute would be like running with one thread for maybe 5 minutes. So almost never parallelization really helps, like times 10 if you use 10 cores. It's more like times 5 usually, but still it helps. The idea of simulated annealing is that you can choose a worse output to work on next at certain probability. Oh yeah, like the easiest version of simulated annealing is that here I allowed for smaller equal. So if something doesn't mess up the score, it makes it a little bit worse. Sorry, if it's the same score, I still want to make a change to allow for more things in the future. And actually it's even better to say that, yeah, if score decreases by a few, let's allow it, because maybe thanks to that some new improvements of size few thousand will happen. So this can be changed to is greater or equal was minus 5, maybe. Or actually this 5 should be some heuristic parameter that with time it gets closer to 0. So earlier, or even better, if I don't have improvement for a long time, for like 10,000 or 100,000, a million repetitions, then you can increase this threshold for how much you can mess up your solution in order to mix it up a little bit. Some other improvement I see here is after I swap something for deliveries 5 and 10, I should now keep comparing things with deliveries 5 and 10, because I know that they are now different, so maybe they will want to swap with somebody else too. What's the score to beat? Well, that's the total score to beat. I now have, I need 2.5 million more. Well, it will be the same here, right? No, wait. Am I missing something in other tests? What's the difference here? 7115, 7112, so that's like 2.7 difference. And does it match? Okay, it matches. I'm 2.7 million short, and just in C, I need score of 714 point something, and I have 711, very slowly getting to 712, but I will not get here. So I would need to experiment with this if I should make it change a little bit more, but I will not do it today. Of course, during a contest, now I spent 2 hours and a half, including talking with the chat a little bit, spending some extra time to, for example, make a drawing. While during a contest, there are 4 hours and there are 4 people, so it's like 16 person hours. And that's significantly more time. You can do more complicated stuff. And it would be, somebody would work on this first part of the algorithm to maybe experiment with those constants, and somebody would work on this. And then at the end, like last half an hour would be mainly to just run everything and make it improve your outputs. Who are your teammates? Just some friends from Warsaw. You will see in the standings, I guess. I would say it's more like 8 hours. Why 8 hours? You mean 2 people will just work 4 hours each, or what? Oh, and now it's really bad. It's like +2, +6, sometimes 1,000. Let's get there. 712 million, please. Is Radeusz your teammate? No, he's not. Right. 9.8. Almost. +2 and +14 doesn't help. I want, how much more? 1,000. I want 20,000 more. Actually, 18,000 more. Isn't it? Why it is? You have a team of 4. 4 people times 4 hours. If you want to say that only 2 people can work, or only 2 strong people are in my team, I don't think that's true. Oh, all right, so this improvement helped. We have the 712. I just wanted 712 million here. It was a very good idea to print new output files and to just let it run forever. Give me 178, please. Yep, and that's a total of 730.6. I don't think that would be good enough to pass the qualification round. Maybe it would, but yeah, if it would be last places in the finals. Or I don't know, maybe I'm underestimating this algorithm. 200 lines, something quite simple. I'm not sure. For sure, only C matters now, if there are like thousands to win in D and E. What was that in E? 773. Oh yeah, I was just 300 short in E. In D I have better score. So like judging just from those scores from Code Forces, it's just C that I'm missing, the 2 million. I don't know, maybe running this for 1 hour more will help to get a million more. So what, in a minute here, let's estimate that I'm gaining 5,000. In 60 minutes, that would be 5 times 60, 300,000. So maybe my score would improve in 1 hour to 731 million. Maybe that would be enough for like top 50. But then actually we should analyze this input file a little bit more. Maybe for every pizza as pre-processing, we should go through all other pizzas and we should exclude some of them. Like I see that me and you, those two pizzas, they have so much in common that they should never be considered together. And that will make the other two parts of the algorithm, the greedy choice and then improvements, it will make them more efficient because they will have fewer choices to consider. I don't know what. And as I said, playing around with this formula should help, and doing something like temperature for simulated annealing, where the more time we didn't have a big improvement, the bigger threshold we should make to how much I can mess up the solution. It shouldn't hurt to mess up the solution by 5 or by 10, because really, even if every iteration you lose, okay, if every iteration you lose 5, that's bad. But those kind of improvements, they should help. And that's it. Another thing to add is, of course, to read from output file. Otherwise, now, if I kill this, I will lose half an hour of computations. That's a bad idea. If you have output files already, then you should be able to read the output file and then keep improving it. Those maybe just should be two separate programs, greedy.cpp and improve.cpp. And one should pass output to the other. And that other, improve.cpp, it should be able to take its own output and print the better output. Right, chat, any questions? I would include the score in the output file name. That's a good idea. Yeah, I think I did it too in the past. We want to do better than 4 people working independently. You know, for sure, a team of 4 can do better than 1 person, but it's hard really to say how much it scales. It's not that 4 people will have 4 times better score, because nothing here is linear. Actually, the score should be the distance from your solution to optimal, theoretical optimal solution. Maybe not theoretical. Just consider exponential solution that tries all the possibilities, and it achieves some score. I would guess from my score here and from this score that the optimal in general should be around 734 million, 734 million. Maybe not, that's not true. I'm just guesstimating. And distance to that, like if you make it twice smaller, that maybe should be considered twice better program. Because to get 730 million and 733 million, that's a big difference, even though it's like 0.5% of improvement, if you just look at your current score. Right, one last submit. And that's it for today. I hope you all enjoyed the stream. I wish you all the best for the actual contest on Thursday. Don't forget to register in advance. I think once the contest starts, you will not be able to join. So make a team in advance. C250 will be output to submit. Yep, this one. So my final score is 730-73-7847. If I have time today, maybe I will do some short post here in Codeforces to share my scores and my code as well. Can you give link to Codeforces? I can, but also you can, Google hashcode 2021 Codeforces. Stupid virtual machine doesn't let me copy the link directly from Chrome. Codeforces.com. Yeah, you're welcome. Right, now nobody is streaming, so no raid. Last stream before the competition? Yes, it is. No, I will not live stream hashcode because that's forbidden. It's a contest. You shouldn't be able to copy my solution during the contest. All right. Thank you all for watching. See you next time.